So given that x squared minus 6x plus 1 gives you all of that, find the value of a and the value of b. Okay, so if you notice that second part of the equation, you got x minus a squared minus b. That's actually known as completing the square, so it's kind of like another type of quadratic. And well, you pretty much have to get that first part and make it look like the second half of the equation. Okay, so how do we do that? Well, the first step you guys have to do for every single completing square problem is to underline the first two terms. Okay, so x squared minus 6x. And then you're going to do a little square bracket and you're going to write x minus. And for the 6, you're going to half it and make it 3. So you can kind of think of it as like you're trying to make a whole square and you got 3 plus 3 is 6. So you always half it. And then what you do next is that you copy the plus 1 and you subtract it by the thing you squared. So it'll be minus 3 squared. And then finally just add 1 and minus 3 squared. So add 1 minus 9, you get minus 8. And then you're done. And you just copy what the a and b values are actually for. Now for the part 2, it says, hence, write down the coordinates of the turning point of the graph of what we just did. Well, the turning point is literally like your equation itself, okay? So you always have to ask yourself, all right, what is the lowest possible point of the graph or the highest point? In this case is when you set x to 3. You always look inside that bracket. If it's x minus 3, that means the x turning point will be positive 3. When you plug in a positive 3, that whole bracket becomes 0 and you're left with y equals minus 8. And that's it. Those are your coordinates of the turning point. Alright, next question guys. So number 20. So let's see. So h is inversely proportional to p. Okay, so you're doing proportionality. So proportional, you always use that kind of fish symbol and you write 1 over p because it's inverse. And every time you use proportionality, we always replace that symbol with an equals k or equals something because it's a constant. Now for the next one, it says p is directly proportional to square root of t. So once again, you'd write in that form and then you replace the proportional sign with another constant, this time equals c, because they're not the same constants, you know, they're two different statements. And we say, okay, where c and k are constant. So always go to like label what we have. Now for the next part, it says, given that h is 10 and t is 144, when p is 6, find a formula for h in terms of t. Right, so looking at the first formula, we got h and p, so we're interested in h is 10 and p is 6. Let's just pop that into that equation, yeah? So for the first one, we're going to have 10 equals k over 6, and then clear the fraction, multiply 6 across, you get k equals 60. So that's our k found. Now for the second part, we use the t and the p value. Again, using the second equation, pop those values in. So you can have 6 equals c times the square root of 144. Well, square root of 144 is just 12. And then divide 12 across, so you get 6 over 12 for c. And that means c equals half. And that's it guys. So now we found the two values. Let's just go ahead and update our k and c, yeah, by putting 60.5. So here comes the main part. Now we need to find a formula for h in terms of t. In other words, we need to combine the two. So combining the two formulas, let's write them down first. So we've got h equals 60 over p and p equals half root t. Okay. So it looks to me we can replace that p with the equation of half root t. So substituting that back in, you get something like this. Now 60 divided by half. That's the same as saying what? 60 times 2, okay? And that gives us 120. Then we have 120 root t, and that's it guys. Alright, the functions f and g are such that, and you're given the definition of them, and here in part A, they want us to find f minus 1x. So that symbol f to the minus 1 is known as the inverse function f, okay? So to find the inverse function of f, what we have to do is use this kind of technique, and this is the technique. You always have to say, alright, let x equals, instead of fx, you're going to let it equal fy. And what that means is that you replace all the x values in that function of f with y. So instead of 3x minus 1, we've got 3y minus 1. And then our equation is basically 3y minus 1 equals x, and you just got to rearrange it to find y. So to do that, you add 1 across, so you get 3y equals x plus 1, divided by 3, and then voila guys, that's your inverse done. And for the second bit, it says given that f g x equals 2 times g of x, show that you can get a quadratic equation. Alright, so what I did guys, I rewrote the f and g functions here just for conveniences. And now to find the first one, f g x, what that actually means is that we're going to substitute a gx function into the function of f. So g inside f. In other words, so instead of 3x minus 1, it'll be 3 times the g function, take away 1. So that's what it looks like. 3 times your g function, take away 1. And yeah, now we just have to tidy it up. So expand it carefully guys, and eventually you get 3x squared plus 11. Now let's repeat it for the other one. Let's try and find 2gfx. So let's just find gfx actually, yeah? So this one means that we're going to substitute f inside g. So instead of x squared plus 4, it will be the function of f squared plus 4. So in other words, we've got 3x minus 1, all of that squared, plus 4. Okay. Now just remember, you got a square bracket here. That means there's two of them. So it'll be 3x minus 1 times 3x minus 1. And then you plus it by 4. So expanding that double bracket carefully, guys, you've got 3x times 3x is 9x squared. Next one would be 3x times minus 1, so minus 3x. Then you get another minus 3x. And then lastly, minus 1 times minus 1 is plus 1. And then write plus 4. And collecting like terms, well, you got 9x squared, you got 3x's, so that's minus 6x, and then you got plus 5. Right, now let's go back to the question. It says, given that fgx equals 2 times gfx, we basically just need to form an equation then. So to form an equation, let's make that equation. So fg equals 2 times gf, alright? So let's copy our fg function first. So our fg was 3x squared plus 11, so okay. And now we're going to equal that to 2 times that gf function. So let's just double that whole equation here. So you should get 18x squared minus 12x plus 10. Now just remember what the question wanted. We need to show that quadratic. So let's make it all equal 0. Yeah? Let's throw 3x squared plus 11 to the other side. So subtracting the other side, you should get your answer. You should get 15x squared minus 12x is the same. And then 10 take away 11 is minus 1 equals 0. And yeah, this one's done too, guys. Yep, and here we go, guys. Our final question, number 22. Let's do this. So, there are only R red counters and G green counters in the back. Alright, so that's basically saying we've got R and G. A counter is taken at random from the back, and the probability is 3/7. So let's say the probability of getting green, so capital G is 3/7. That's basically the same as according to our bag. It's like taking the G out and you still got R plus G. So that's basically total. A total is R plus G, yeah? Now the counter is put back in the bag. 2 more red counters and 3 more green counters are put in the bag. So in other words, you still got your original R. Now you got R plus 2 and you also got G plus 3. And the probability that you've taken that counter, which is green, is 6/13. So probably taking the green again, based on the new information, well, it's going to be 6 out of 13, which is also equivalent to, well, G plus 3, because that's how many greens you got, over the total amount, which is R plus 2 and G plus 3. Okay, so just adding them up. And let's just tidy up the bottom for a second. So you still got G plus 3 on the top, but on the bottom you got R plus G now. And you also got, what, 2 plus 3, which is plus 5. Okay, so that's cool so far. And the question wants us to find the number of red counters and the number of green counters that were in the bag originally. Okay, so what you want to do here is you want to work this out simultaneously. So let's circle the two equations we got, yeah? 1 of 3/7, 1 of 6/13. So let's rewrite them below now. So we have 3 over 7 equals, what is it? G over R plus G. And what we want to do here is clear the fraction. So let's multiply R plus G and 7 across. So what you're going to have is 3 times R plus G and 7 times G. So expanding the bracket, you should have 3R plus 3G equals 7G. And let's just move 3G to the other side, and then you're going to have 3R equals 4G. So what we done, we just more or less simplified the equation, right? Now let's repeat the same for the second equation. So we've got 6/13 equals G plus 3 over R plus G plus 5. Once again, cross multiply, so times 6 by the R plus G plus 5, and 13 by G plus 3. Okay, so it should look like that. Now, expanding both sides of the brackets, so you're going to have what? 6R plus 6G plus 30, and that's going to equal 13G plus, well, 13 times 3 is 39. Now, you can do this any way you like, but what I'm going to do is just probably move the 6G and 30 across here, because you've got 6R on its own on the left. So, subtracting 6G across, you get 7G. 39 take away 30 is plus 9. Alright, so what we have here now, again, is 2 simultaneous pair of equations, right? So we need to think about how to deal with this. Now, what we could do is pretty much use probably the result at the top. We've got 3R equals 4G, and we've got 6R at the bottom. My advice is probably multiply the top one by 2, so then you get 6R equals 8G. So then you have 2 6R equations. And what that means now, you can pretty much substitute the 6R of the first one, which equals 8G, into the second one. So replacing 6R of 8G, you basically have this. 8G equals 7G plus 9. Now subtract 7G across, guys, you get G equals 9. And that's it, you found your green. And for the last bit, just substitute this value of 9 into any equation. I'm picking the 6R plus 8G one, that easy one we had earlier. So plug in 9, you get 6R equals 8 times 9, which is 72, divided by 6, guys, and you get 12 red counters. And yeah, that's it. And this is the end of the paper. I just want to thank you guys for coming to this end of my channel, and if you've enjoyed the content so far, just go into my channel page, hit the subscribe button and hit the bell for more notifications, and if you want, you can do personalized or all, and that way you won't miss any future maths or educational videos. Anyway guys, thank you for watching and see you next time. Ciao.